Okay. So let's start. Last time I showed you, right, that if I took two goods and I decreased the price of one of the goods, we're playing with our indifference curve, the one on the horizontal axis, and as the price went up and down, right? Or as the price went up, people demanded less, as the price went down, people demanded more. And we constructed from that indifference curve, we constructed our demand curve. That demand curve was for an individual, right? Now, I can sum those up and get what we call a market demand curve. In other words, if I take the demand curves of every individual that demands that product, right, I get an industry or market demand. Right? So I have more than one good. Nicely depends on the price of all goods and the income of everybody. Right? Since there are too many variables and prices and income, I'll assume that except for the price of the ice good, all the other prices are kept constant. In other words, that's not what we can do our partial derivative, we hold all the other prices constant. Right? So I can draw my familiar demand curve. To find the market demand curve, all I do is add up the individual demand curves horizontally. So this is a background. So I can think of these curves as individual demand curves, and then this final curve as a horizontal. So in other words, at this price, this person demands this much, this person demands this much. As someone goes to, and I get at that price, and I do that for every price, right? I sum up all the individual demands and I get the market demand. Does that make sense? Okay. So a market demand curve, right, is going to depend on the price, right, and the price of all of the goods, right? All related goods, whether they're complements or substitutes. Now, granted, they don't need to be perfect complements or perfect substitutes. They just have to affect the demand for this good. And in a sense, almost all products are, almost the majority of products are substitutes. Why? Because the money I spend on those products is the money that I can't spend on this product. So if I change the distribution of income and I keep the total, wait, I'm getting ahead of myself. It all depends on the ice price and the price of all of the income distribution. If I take the distribution of the income, even if I take total income constant, demand is going to change. So the aggregate demand depends not only on total income, but on who has it. So my market demand is going to depend on the price of the good question, the price of all other goods, and the income of everybody in the market. And it depends who has how much income. Why? Because we all have different tastes. If the rich people really like, I don't know, gummy, then the demand is going to be high. Right? But if you change that income and only poor people like gummy bears, well, the demand for gummy bears decreases. It depends on who has the income for an industry. Okay. So now, last time we derived individual demand curve, we have a concept of market demand curve, right? What I want to talk now about is the slope of the demand curve. We know it's downward sloping, right? So I know more than one thing affects the demand for that. I know the price of that good, or the price affects the demand for that good. I also know the prices of other goods affect the demand for that good, and I know income affects the demand for that good. There are other things that affect the demand for that good, things like advertising, weather, and really a whole host of other things. Some of which we'll talk about, some of it we'll just kind of leave up in the air. But there's a bunch of stuff that affects demand. Right? But if you hold everything else constant except the price of the good, like this, I can take the price from the next high with respect to its price and get its slope. In other words, I get how the quantity demand changes when price changes. Right? So if I have a demand curve that looks like this, right? Its slope is going to be big. Its slope. If I have a demand curve, it looks like this, it's relatively flat, and that number will be smaller. Okay. And the slope kind of tells me how quantity demand changes with price. The problem is that slope is unit dependent. Right? It depends on how we're measuring. And the example that I have here is I can measure pounds per dollar. That's the weight of pounds, not British pounds. Or I can do the same thing in grams per yen. Now, it's the same product, it's the same good. The demand should be the same, but the slopes are different because we're measuring different things. Well, actually, I shouldn't say. We're measuring the same thing differently. So instead of looking at the slope, here, the big changes. The truth is we should use the partials because we know there's other things that affect demand. But for now, we're using big changes like a partial, assuming everything else is constant. Okay? So slope isn't a good measure of the change in demand, or the change in quantity demanded. So we need something else, and for that, we use something known as elasticity. Right? Elasticity is a percentage change in a dependent variable resulting from a 1% change in another variable. That's the generic definition of elasticity. I can use it for any two variables that have a relationship. Actually, I can use it for any two variables, period, even if they don't have a relationship. I just mean elasticity is going to be 0. Okay. So, in this case, I can instead of saying change in XI, we change and the percentage XI over the percentage change in P. I can rewrite that as follows. I can write it as the change in XI over XI, and change in PI over PI. Right? Now, here it doesn't matter if I'm measuring pounds per dollar or grams per yen. I'm going to get the same number. I can say something like a 1% change in price will result in a 3% change in demand. In that case, elasticity is going to be 3. Actually, it's going to be -3. Why? Because the percentage change in in one of these has to be negative. So if this change is positive, then the change in demand has to be negative. Why? Because demand is downward sloping. And for that reason, when we talk about elasticity and demand, a lot of times we use the absolute number instead of raw number. Questions? Now that I have this, right? I can do a little algebra, and I get something like this. So writing on the board, I have the change of xi over xi divided by the change in pi over pi. I can write the change of xi, right, and I can write the change of xi as the number where we end up with minus the number we start with. Here I'm just going to call them 1 and 2. So I have the change in xi is x2 minus x1 divided by where we start off with x1. I'm going to divide that by the change in pi, and again, assuming we end up with +2 and we start with +p1. So the change in pi is q2 minus p1 divided by p1. Now that I have that, how did I get from here to here? Oops. Well, I just did a little bit of algebra. I have the change in xi over xi, the change in pi over pi, and doing algebra, I can bring xi into the denominator and write that as the change in xi over xi times the change in pi times pi. Now, I'm divided by pi. Now I have something in the denominator of the denominator. That means I can bring it up to the numerator. Okay? So, bring that, I have xi times the change in pi in the denominator, and in the numerator I have xi times pi. And I can rewrite this as pi over xi times the change in xi over pi. Now, I have these in deltas, right? But it's still a change, and I can write them as a derivative, or in this case, as a partial. And that's how it goes from this. Over here, we have in the board pi over xi times xi over pi. The change in xi is a pi over xi times a partial of xi with respect to pi. So I go from the big changes to the infinitesimal partials. Okay. Now, in this case, we've gone from general elasticity to elasticity of demand. Oh, and one last thing, I forgot that here, as I told you, this is going to be a negative number. So over here, this is why we take the absolute value of the number. So if I have a linear demand curve, right? There are some properties of elasticity that apply to a linear demand curve when we're working with them that are interesting. That is that at the intercept, right? The elasticity is basically infinite. Right? Down here, where it hits the horizontal axis, right? It's basically zero, and therefore it's really big, gets small, and at some point it gets what we call unitary elasticity. That is when elasticity is equal to 1, and then it goes on to be. Okay. So here's the algebra that I did on the board with the general elasticity with y and x. So I have the percentage change in y divided by the percentage change in x. I go ahead and rewrite that, right? The way I have it over here, the change in x or the change in x over x. I'm sorry, the change in y over y divided by the change in x over x. And I rewrite that as the change in y divided by the change in x times x over y, doing the same algebra we just did right here. Right? And as I said, this applies to demand and supply, and we can really apply it to basically anything, any relationship of two goods, right? And it applies to any dependent variable that is affected by independent variable, as per the definition. So point elasticity, right? The percentage change in y with the percentage change in x. They give me a change in y over y divided by the change in x over x. And I rewrite that the way I have it up top, the change in y over the change in x times x over y. And then I take those big changes and I make them partials. Partial of y with respect to x times x over y. Now, when we work with elasticity in this class, we're almost always going to be part of this. We talk about elasticity, but we're always going to work mathematically with elasticity just because it's simple. And more importantly, when I get elasticity, right, you can calculate it in one of two ways depending on the information I give you. Right? If I give you percentage changes, you go straight to the original formula. Right? So if I give you numbers where you can calculate the percentage, I give you numbers where you can calculate the percentage change, then go to the original formula. You say the percentage change in y over the percentage change in x. If it's demand, it's percentage change in the quantity demanded over the percentage change in price. If I give you a formula, on the other hand, where you can calculate the slope, well, that's what you have to do. You take the derivative, and then if I give you numbers for x and y, or demand, or quantity demanded in price, you put those in. If I don't give you those numbers, you just put, right, Q and P, or x and y, whatever they might be. Okay. I told you we're always going to work mathematically with point elasticity. There's another type, and that's arc elasticity. Point elasticity, right? Suppose we have a demand here. Point elasticity gives you the elasticity, as it says, at a given point. Right? Arc elasticity, on the other hand, gives you the average elasticity over a range. So from here to here, it'll give you the average elasticity between the points. So arc elasticity, right, is the change in y over average y divided by the change in x over average x. And I can rewrite that as y2 minus y1 divided by y2 plus y1 divided by 2. And that's just the average. Right? y1 plus y2 is the average of those 2 points divided by 2. Of course, your 2 observations, that's divided by 2. All divided by x2 minus x1. That divided by x2 plus x1 divided by 2. Again, this is the average x. This is average y. Right? Now, this algebraically, this 2 cancels with that 2, so it goes away. So I can write y2 minus y1 as a change in x. I can bring this up to the top. I can leave this in the denominator. x2 minus x1 is a change in x. And then I just bring this up to the denominator, leave this in the numerator, leave this in the denominator, and I get my formula for arc elasticity. Right? It's just that way. But It's a little more difficult to work with than point elasticity, and we really don't gain anything conceptually with it. So for the most part, we're going to, actually, the rest of the class, we're going to work with point elasticity. Questions?
Can you use more than 2 points in the elasticity?
I'm sorry?
Can we use more than 2 points?
If you use more than 2 points, you have 2 ratings, and you have to calculate 2 elasticity. And basically, in that, for instance, let's say I have 3 points. I have 2 choices. I can calculate the elasticity with the same hand here, and then put the hand out. Or I can take the whole thing, which is 2 points anyway. Okay. So the price elasticity demand, right, is simply the responsiveness in the quantity demanded. Remember, we have to be careful when we talk about demand. Quantity demanded means we're moving along the curve. The change in demand means the curve shifts. So here the price elasticity of demand, the responsiveness of the quantity demanded are changes along the demand curve to changes in the price of the product, holding constant the value of all other variables in the demand function. And we're going to denote that by epsilon. So remember that epsilon is negative, since the demand curve is downward sloping, right? So the absolute value, when the absolute value of elasticity of demand is greater than 1, we say demand is elastic. What that means is when there's a price change, you get more of a change in quantity demanded. For instance, if I have a 1% change in price, quantity demanded will decrease by more than 1%. If point price elasticity or the absolute value of point price elasticity is equal to 1, we say it's unitary elastic. That means if price increases by 1%, the quantity demanded will decrease by 1%, 1 for 1. And finally, if the point price elasticity is less than 1, we say it's inelastic. Right? What that means is if price increases by 1%, the quantity demanded decreases by less than 1%. Now, if I'm selling a good, one person selling, I want a good that is inelastic. Why? Because when I increase price, right, my revenue goes up. My revenue goes up because the quantity demanded for my good when I increase price decreases by less in percentage terms than what I increase price. Right? If I'm in the elastic portion of my demand curve and I increase price, my revenue is going to go down. And we're going to talk about all this stuff a little later. Well, this is what I said. So this, with elastic demand, the change in price changes the quantity demanded by a larger percentage than the change in price. This means that every time I increase price by 1%, quantity will decrease by more than 1%. Therefore, revenue will decrease when price increases. Then the decrease in quantity demanded. And the opposite happens with inelastic demand. Right? And of course, with unitary elastic demand, you get no change in revenue. So we're going to define total revenue as price times quantity. Listen, the amount you sell times the price you sell it for. Doing a little algebra and calculus, at least the calculus part you're not responsible for. I can write the change in total revenue, which has 3 parts, as P times the change in Q plus the change in P times Q. That looks a lot like a rule we looked at the first day, that again you weren't responsible for, but does anybody remember? Not quite. Chain rule was later on.
Oh, yeah, it was like the first rule where the multiplication rule. No, that's not the
It's
chain
close,
rule, right?
it's close.
Multiplying.
I think somebody said. Quotient rules when we're dividing, this is multiplying. Product rule. Sorry. Product rule, because we're multiplying. So your logical first or multiplication rule, whatever.
Yeah.
But what you were saying is exactly the rule you want. You gave a name, a logical rule, not quite the right name. So it's P times Q times the change in Q plus the change in Q times Q. That's a lot like the product rule over the change in Q. Right? So I'm just rewriting delta PR over Q. So I got to go ahead of myself. I was showing you how to do it before I define MR. MR is marginal revenue. And marginal revenue is simply the change in total revenue over the change in quantity demand. And now that I define marginal revenue, right? And I told you we can do something very similar to the product rule here, logically. I can go ahead and manipulate marginal revenue, right? I can rewrite it, first of all, by multiplying both sides by Q. Over here I had P times the change in Q. So here I'll get P plus delta P divided by delta Q all times Q. So going back here, I have P times delta Q. Delta Q over delta Q is 1, so I'm just left with P. And therefore I have delta P over delta Q times Q. Everything times Q. So I can rewrite this, right, simply by multiplying it by 1. It's one of those cheesy algebra tricks, right, that when you want to do something and you can't really figure out if you multiply it by 1, and then just rewrite 1 as P over P in this case. P over P is 1. So I can rewrite that. Over here, I'm going to take P down in the denominator, so P over P times P. And I'm going to have delta P and delta Q, which I 4. And over here, I have, okay, so I have P over there, and P over here. I keep meaning to do this for the video in case you guys want to look at it later. So I have P over here and P over here and P over here. So I can just take it to the outside. So I have P 1 times delta P over delta Q times P over Q. This right here looks a lot like elasticity, but it's backwards. It's essentially the inverse of elasticity. So I can rewrite it over delta Q divided by delta P times P over Q. So this is elasticity. So I get 1 plus 1 over epsilon P. What this tells us is that marginal revenue, that is the added revenue that I get from increasing my quantity, the quantity that I produce or the quantity that I sell, my added revenue is going to depend on the price of times 1 over 1 plus my elasticity of demand. Right? So my elasticity of demand, just like we did logically over here, affects your revenue. Right? So if I raise price or decrease price, that's going to affect my revenue. If I increase or decrease my quantity, that's going to affect my revenue. But when I change the quantity that I'm producing, the amount my revenue changes by is going to depend on questions. Again, even in this case, I prefer inelastic demand, right? Because I'll get more revenue, even when I'm only changing Q and not P. And of course, the reason for that is remember this is no longer so it's going to be a smaller number than 1, but negative, right? So my marginal revenue in that case, right? I want that number, right, to be, or the whole number 1 over epsilon p, to be small. That way, my marginal revenue increases by more. Does that make sense to everybody? Okay, I didn't like that. Okay. Hopefully now this makes a little more sense. So given that we can see some marginal revenue, when demand is less than -1, right? So my marginal revenue is positive. When it's inelastic, that means better than -1. So the marginal revenue is negative, and unitary elastic negative when the marginal revenue is zero. That's when I change my QB. So notice the elasticity here needs to be measured in real terms and not absolute terms when we're doing the formula. What we do it in absolute terms, right? Because most of the cycles think it's positive, and it was a bigger number is better or whatever. So if we're talking about elasticity, a bigger number means that it's more elastic, right? So that bigger number, right? If it's negative, the bigger that's the real number, that means the smaller number, the smaller the number actually is. So that's why we do it in that group. Okay. Does this make sense to you guys? Because you guys looked at me with the big eyes when I was saying it a while ago. Okay.
Elasticity is preferred. Why then is marginal revenue?
Oh, you're. Did I say that?
Yeah.
Okay. Thank you. Okay, my bad. Inelastic. I want inelastic demand if I'm raising price. If I'm increasing the quantity, I want elastic demand. Because that'll increase my marginal rate. Okay. If I nobody, I apologize. No one of you guys are giving me that funny look. Okay.
¿Puedes repetir lo último de la cantidad?
¿Eh?
Lo último que dijo, que si...
Ok. Si yo cambio el precio, ¿verdad? Yo prefiero que la demanda sea inelástico. Porque en ese caso, mi ingreso sube más cuando sube el precio. Si estoy aumentando la cantidad demandada, la cantidad producida, entonces yo prefiero que la demanda sea elástica. Make sense? Okay. A little bit, if I misspoke a while ago, that didn't make any sense, and that's why you guys are looking at me weird. And I apologize. Okay. Any more questions before we go on? Okay. So we'll learn that profits can be maximized when marginal cost equals marginal revenue. We'll talk about. So if, and we're going to prove this later on, but right now I just want to show you this so we can get to this one right here. Therefore, the profit maximizing price can be written as a function of the system. So it's marginal revenue equals marginal cost, and I know marginal revenue is equal to this here, right? So marginal revenue equals marginal cost equal to this, what we just showed. So therefore, I can solve for P in this case. I get price is equal to marginal cost divided by 1 over 1 plus the elasticity of demand. This is known, right, as markup above marginal cost, right? So how much above marginal cost I can charge depends on my elasticity of demand, right? So what do I want epsilon P to be here? Sure. The amount that I can charge, make it point up here. I'm supposed to do it here. The amount that I can charge, right? Above marginal cost, right? It's going to depend on elasticity, right? So do I want elasticity to be a big number or a small number? Elasticity, I want to be a small number. Okay. Remember, elasticity is negative. If I have 1 over a small number, what do I give you? A bigger number. Let's say it was 0.5. If epsilon was 0.5, right? Negative 0.5, right? What would this be? 1 over epsilon. Negative 2. So I have 1. Right, so I have negative 1, so I have P is equal to marginal cost over negative 1. So I have basically a negative markup. I don't want that, right? Basically, what I want, right, is epsilon to be a big number. I want it to be elastic in this case. I want it to be really elastic so I can have my price well above marginal cost. Okay. So we've talked about basically up to this point general elasticity and we call price elasticity or price elasticity demand. So this we're going to call price elasticity demand. It's a percentage change in XI or the percentage change in PI. We also have different elasticity of demand. The next one we're going to talk about is cross price elasticity of demand. Right? This is the change in the quantity demanded of I with respect to the percentage change in the quantity demanded of some other good or the price of some other good. We'll call it J. That's the cross price elasticity of demand. In other words, if I'm selling apples, the price of oranges is going to affect the demand for my apples. So how much it does is going to be measured by our cross price elasticity of demand. And finally, income elasticity. Go ahead. In this case, for most cases, Apple and oranges are substitutes.
Well, that's what you use for these two items have to be.
They don't have to be substitutes. They can be complements. But it's whether they're complements or substitutes is gonna affect the sign of the system. Right? So if they're substitutes, it's going to be positive. If they're complements, it's negative. So in other words, if the price of oranges increase, the demand for apples will increase. So it's positive. Those two are substitutes. Right? If they're complements, peanut butter and jelly, the price of jelly goes up. Right? The demand for peanut butter will go down. In that case, it'd be negative. And finally, the last one we're going to talk about is income elasticity. It's basically as people's income increases, what happens to the demand for XI. And again, like cross price elasticity depends with the, excuse me, with the complement or substitute. Income elasticity, the sign is going to depend on whether it's normal or an inferior good or a luxury good. A luxury good would mean that it's positive, but income elasticity is greater than 1. If it's between 0 and 1, we call that a normal good. If it's positive, but for every dollar I get, my demand, or for every dollar for every dollar my wealth increases or my income increases, my demand for that product will go up by less than $1. That's just a normal good. In other words, I like that good, I'll spend more on it, but I'm not going to spend all of my added income on it. If for a luxury good, right? My demand will go up by more than that. And finally, for an inferior good, it's gonna be negative. I become richer, I buy less. Okay. So let's start with, we've already done the own price elasticity of demand. Let's do cross price elasticity of demand. I have the percentage change in Xi over the percentage change in PJ. I just do the algebra I did before. I get the change in Xi over Xi divided by the change in PJ over PJ. I can rewrite that as a change in Xi over the change in PJ times PJ divided by Xi. And of course, I can take these deltas, or the big changes, and make them small changes, make them into partials, and I get the partial of Xi with respect to Pi, I'm sorry, with respect to PJ. It looks like an I because it's tucked there on the bottom. Can I make this big? No. So the change in Xi over, or the partial of Xi with respect to PJ times PJ over Xi. And that's a definition of our cross elasticity of demand. Okay. As we said, we have substitutes. Right? Then the cross elasticity if the complements are negative, if they're independent, right? The price of one doesn't affect the other, then it's zero. Like I said, for most products, most products are substitutes. Simply because if I spend $1 or if I spend $1 on one thing, I can't spend it on another thing. But for a lot of goods, that number is going to be pretty close to zero. We can, for all intents and purposes, say they're independent. Okay. Income elasticity. It's the responsiveness of demand to changes in income, holding all other variables constant. I do the algebra. The air conditioner's off today, huh? Okay, I do the algebra. Did I go too fast to the next slide? Okay. So I do the algebra now. I get the product of the percentage change in income I. I can write that as delta Xi over Xi divided by delta I over I. I can rewrite that as delta Xi over delta I times I over Xi. And of course, I change the big deltas to partials, and I get the partial of Xi with respect to I times I over Xi. Now, we already spoke about when these are inferior goods, right? The income elasticity is going to be negative. When they're normal goods, the income elasticity is going to be between 1 and 0. And when they're luxurious inferior goods, income elasticity is going to be greater than 1. If we think about this in macroeconomic terms, is how the recessions, or whether we're in recession or zoom or things that are just okay, right? We're in a recession, right? What happens? Income comes down, so we can think of income coming down, and what's going to happen to inferior goods. Inferior goods, that demand actually going to rise, right? Because we get poorer, we buy more. Normal goods and luxury goods, demand is going to go down. It's going to go down. It's going to go down more for luxury goods. So we can think of those as cyclical. These are non-cyclical. Basically, they have an income electricity close to zero, right? And we buy those in recessions, and we buy those when things are going well. These are two slices in the toilet paper. So if they're going to buy them up. But inferior goods, right? We can think of those as counter-cyclical, right? When we're in recession, we buy more of them. When things are going good, we buy less of them. And normal goods and luxury goods we can think of as pro-cyclical. Things go up, things go down. Now here, I count normal goods, right? Like I said, gold, petrol stuff. That when income goes up, we buy more of them, but we don't buy that much more. But we buy more. Questions? Okay. Other measures of elasticity. There's probably a ton that I can't think of. But the ones that are out there that are pretty obvious, things like advertising. We have advertising elasticity. If I spend $1 more on advertising, what does that do to my quantity demanded? Weather elasticity for different goods. They have a measure called high bulb temperature. And that basically measures both humidity and how hot it is. Right? That'll give us an estimate of when people are going to go out shopping, when they're not. Of course, there's also humidity or precipitation. If it's rained a lot, if you live in a tropical island, we can think of the wintertime when it gets really cold. The precipitation in that case is snow, and snow makes driving difficult, things like that. There's also things like heating oil, right? When things get cold, right? People heat their homes back up north, and they demand more heat, more fuel. And finally, interest rates, right? This is very important for durable goods, things like washing machines, cars, etc., where things that we don't always buy outright, but we have to borrow to buy, and the interest rates might affect those. And like I think we could probably think of a bunch of other ones, and no matter how many we think of, there's probably more things that affect demand that we can measure. Okay. This is ugly. This is a Marshallian demand curve for X in terms of PX. Note that the only two variables that affect X here are income and the price of X. I don't have another variable out there, PY or PJ, that affects my demand for X. Why do I have this? More advanced class. And the reason I take this example is and I just couldn't think of another simple example. So what I'm going to do is I'm going to go through this example, and don't worry about the math. Try to think of it conceptually. And then we'll go through and we'll do simpler examples. Okay. The first thing I want to do is I want to find the own price elasticity of demand for X. That means the percentage change in X over the percentage change in PX. And I can do that by taking the partial of X with respect to PX times X over PX over X. So the partial of X with respect to PX times PX over X. So how do I do that? The first thing I have to do is take that ugly demand function and take the partial with respect to PX. So here, and don't worry about it if you don't get the calculus, because you're never going to be responsible for this. But the partial
right? I have px in the numerator. I, in this case, since it's not the variable I'm concerned with, is a constant, so it's just multiplied by 1 over px. And then I have 1 plus 3. Let me go back. Oops. I have 1 plus 0.75 over 0.25. 0.75 over 0.25 is 3. I probably should just wrote it as 1 plus 3 or just 4. Yeah, I'm not sure why I did that. Hopefully I can change it. I don't know why. I mean, I know why I did it for the other class, but I don't know why it wouldn't just change it. Anyway, we're getting away from, so basically I had 1 over px, so that's px to a negative 1. So the derivative of that would be px to the negative 2, right? Times whatever we're multiplying. Negative I plus 3 or 4 times px squared or here I 4 times px squared over px or px constant. So I get I over 4 times px times x. Again, don't worry about the calculus, but what did we do, right? I took the partial and I multiplied that by px over x, right? And that's how I calculated the elasticity. That's for the own price elasticity. How about income elasticity? What would I do? Come on, guys. I know it's late. I know you're tired. Somebody's got to help me out here. What would I do for income elasticity? For own price elasticity, I take the partial of x with respect to px and multiply that by px over x. Over here, what would I do if it's income elasticity? Okay, I think on all three, I think we got it there, right? I take the partial, right? X is defined in that with respect to I, and I multiply that by I over x. So when I do that again, I don't know why I'm doing this, and I'll just call it 4, but it doesn't matter. But in this case, right, that partial is I times a constant. Why times a constant? Because the rest of that stuff is not what we're concerned with. We're holding all that stuff fixed, therefore constant. So it's just 1, the partial is just 1, 1 plus 3 px over 1 plus 3 px. Right, that's a partial 1 over 1 plus 3 px times I over x. And then I just do the algebra. I get I divided by 4 pxx. And that's income elasticity. I'm sorry? Actually, yes, but that's not a rule. There's no logic to that. It just happens. But yes, it's just the inverse of, well, the mirror of own price elasticity. With respect to I? So I can write this. I can write 1 over, I'm going to call it 4. Yeah. And I can write it this way. So this is a constant. Okay. So now I just have that. So I take the derivative of this is just 1 over 4. Right? And that's what the constant. Again, don't worry about the math here. It's a little more complicated than we need and that we're going to use. So cross price elasticity. Now, what did I say? Oops. When I first talked about this
are showing demand function? Okay. I know, that was like 3 minutes ago, you guys don't remember, that's fine. But so what's the cross price of elasticity of demand in this case? I'm sorry, somebody said it. The partial of X with respect to some other price. Where's the other price? We don't have it. Perfect. So what would the partial be? Actually, we do know it because that's what demand is. We know that's demand, or we're assuming that's demand. So let's call the other price PY. What would be the partial of X with respect to PY in this case? Because PY is not there. It is, help me out, guys, come on. Somebody said it. After they said 1, they said something else. 0. It's 0. There's no PY here. So it's kind of a trick question, but that's why I try to tell you at the beginning there's no PY. So here it is, the partial of X with respect to PY times PY over X. Well, because there is no other P in the demand curve. Okay. Now that how realistic that is, I don't want to get into. For most things, there's something that affects the price simply because you're spending money elsewhere. But for that was the function that we were given. That's what we were working with. Now I want to do the same thing again, but with a simpler, right, demand function. In this case, a linear demand function. I get X is equal to constant 2 minus 6px plus 3py plus 2i squared, where px is the price of X, py is the price of some of the good, and I is the input. So what's the own price of elasticity? I'll give you the function here, right? The percentage change in X over the percentage change in X, I can calculate by the partial of X times X. Now going back to the formula, right? -6. Oh, did I get it? I thought somebody said it, sorry. Okay. Times -6 times you're leaving something out. Okay. What was the partial again? Of X is expected to X? -6. So this first part is equal to -6 plus -6 times. And that means not here. There's no numbers associated in this case. The actual X. It's just like the example we did right at the beginning of class, right? So the whole question was just that. -6, which is the partial of X expected to X, and Px over X. Questions?
I think I was confused with the expecting the number
With the Px and
the
X.
X on the bottom.
It's just algebra. It's possible I could give you numbers, but in general, this is we want the general formula for elasticity. In this case, right, it's going to be the partial times Px over X, and depending where you are on the demand curve, right, what Px is and what X is, it'll give you a number for elasticity. But it's going to change as we move along the demand curve.
So for now, we just want the formula. Okay. What's the income elasticity? Oops. So let me go back to the formula. Okay. 4i would be not income elasticity, but it would be the first part that we need, which is the partial. Perfect. So we take the partial, which in this case, I have 2i squared. So I take the square down here, 2 times 2 is 4, so it's 4i times I over x.
Okay.
I get 2 times 2 times I, and I over x equals I times I, which is I squared, so it's 4 I squared. Since that's positive, this is basically a luxury good. Okay, questions? Okay, so we've done own price elasticity, income elasticity. What's left? Cross price elasticity. So going back to the formula, what do we need? The partial of x with respect to py, and that's going to be 3. Well, you're jumping ahead of me. The partial is 3. Py over px is the whole elasticity. So here we go. We have the partial of x with respect to py is 3 times py over x. So the elasticity is simply just 3 py over x. Okay. That's positive. That means y is a substitute for x. If it was negative, they'd be complement. Questions? I'm sorry? Own price elasticity?
Where's the other? What are these?
I'm sorry?
Isn't it between two?
Yes, in this case, it's between y and x. So it's the price of y. I don't know what the demand for y is. But then again, I don't care because I'm only concerned about x. So it's the price of y, right? So it's the partial of x with respect to the price of y times the price of y over x. Y is another good. That's why it's a cross price elasticity and not an own price elasticity. Am I good? Okay. One more time. This time, no numbers at all algebra. Letters. Okay. Now be careful because here I is just I. And di is not I'm not taking the derivative of I, it's just d is a constant and I is income. Okay. So the first thing we're going to do is own price elasticity. Perfect. The partial of px, the partial of x with respect to px, which, as you said, is negative b. And to get the elasticity, I just multiply that partial by px over x. Okay. So our own price of electricity, right? People still writing, sorry guys. I know some of you guys are looking at me, why aren't you going on? But I try to wait till pretty much everybody stops writing. And that doesn't mean if you're writing that you have to hurry, just do what you have to do. Okay. So the elasticity therefore is a partial of x with respect to px over x. Which, and the partial is just negative b. So the partial of x over px is negative b times px over x. And that's the own price elasticity of demand in this case. Next on to income elasticity. Oops. What does the percent need to do? Take the partial of x with respect to I, which in this case is d, times I over x. So I take the partial of x with respect to I, which is d, and multiply that by I over x, so I get d I over x. Of course, if d is greater than 0, it's a normal superior good. If it's less than, it's an inferior good. Find the cross price elasticity. In this case, which partial do we need to take? The partial of x with respect to py. Perfect. Okay. You guys are flying. You're getting the hang of this. So I get the partial of x with respect to py, which is c, right? Times py over x, so I get c, py over x. Everybody with me so far? Okay. In this case, if C is positive, they're substitutes. If it's negative, they're complements. Okay? So now let's just talk about the real world instead of the concept of utility, which, like I said, we made up numbers. Which products in the real world do you believe are inelastic with respect to the rent? Usually I have you write on the paper with 2 columns, but I think there's just one that you easily can write. But we talked about it, it's not so bad. So what's something inelastic that when the price increases, we're gonna buy?
Even if you increase the base.
I'm sorry? Water? What's the water is huge supply, so you don't have to big price increase. At some point, right, water would be very high.
Well, not necessarily. That's the kind that you're eating out.
Food,
Basic, I guess.
I'm sorry?
Basic.
The thing with food, right, and water, even though this is the supply, and for food, there's a lot of substitutes. And I'm not talking about food in general, I'm talking about one food source and the other. Water is just a ton of supply. So those would actually be inelastic if you have like pricing. What else you think might be inelastic? You're gonna buy them on
Medical
medicine, that's something like the cancer medicine, that you really need to survive, that's gonna be, the medicine that's gonna be very high. Everything is perfectly elastic. They can't raise the price forever, because at some point people can afford it. But it's very elastic.
Yeah.
What else? How did you guys get here?
Yeah, someone mentioned gas. It's surprising.
I didn't hear somebody mention that. It's usually the first thing I see mentioned like that. Gas.
Can't try to save gas, but
Gas, at least in the short term, right? Gas is very elastic. You need to get places. You need to get to class, you need to get to work. So you're gonna keep buying gas, even when the price rises, at least in the short term. In the long term, people figure out ways around it, right? In the long term or longer term, gas is more elastic. It still might be inelastic, just a little below one, but it becomes more elastic as time goes on, right? People do things, they carpool, they buy more efficient cars, etc. Anything else? Okay, that's cool.
maybe
What
it's
product?
energy, but
Energy, but especially the generating oil, heating oil, right, of north, you gotta heat your home. I mean, again, it's elastic, again, longer term, it's inelastic. People will start figuring out other ways. I gather around the fire. Burn wood, whatever it might be. Switch from home heating oil to some other kind of heating source, electricity or whatever it might be. Okay. Now, what products out there do you think are elastic?
any appliance, basically.
Appliances? Okay. So when the price goes up with the stove, I hold on to my stove longer. In my case, I have a burner and a half on my stove that don't work. One that kind of works. And then I basically the other two work. And I've been thinking about buying a new one, but I just, I just can't convince myself to spend the money. What else might, be elastic? Sorry? Cars? Luxury, there's any luxury, right? Luxury cars, what else? Cell phones.
Yeah. Okay.
It's elastic or inelastic?
It's elastic. I never wear it once.
What else? Clothes? Perfect.
Yeah.
We wear their clothes, we wear a little more faded pants, or if they might be, instead of buying, going to the store and buying a new car.
In terms of a manufacturing, we can raw materials.
Sorry?
Raw materials, it can be elastic.
Raw materials,
I can change, if I buy product A, if price increase, I can buy product B two with the same performance than the A.
anything that where there's a substitute is generally elastic, like you say. If I can switch, if the price of this goes up, I'll just switch it to something else. For some things that are elastic, like gasoline, I can't switch tomorrow to buy, and plug in my car to my home, right? And that takes a while. But anything where there's a quick and fast substitute are generally more elastic. Okay, anything else? All right, well, that's basically the discussion I wanted. What factors might affect the product's price elasticity? That was one, whether they're substitutes, right? Perfect, that's number one. The degree to which it's a necessity. We talked about water and heat. Those are definitely elastic at some point, right? We usually don't take them as elastic because This is comes from fire. Number three, the proportion of income spent on the price. How much of my income am I spending on it? Right? If I'm not spending a heck of a whole lot on the price increases, well, I'm still not spending a heck of a whole lot after the price increases. Okay. Now, this gets to what advantages does a manager have by knowing how elastic a product is with respect to its own price? Well, it tells me how much pricing power I have. And the pricing power is important. Can I raise the price, right, without significantly lowering my revenue? Okay. What about other types of elasticity, right? For instance, cross-price elasticity, right? What happens to the demand of my product when the price of other products change? What happens to the demand of my product when the advertising increases? What happens to the demand of my product when we're in a recession? And what happens to the demand of my product when things are going well? Things of that nature. Okay. And we talked about income elasticity. How about advertising elasticity? It's nice to know, right? If I spend an extra dollar on advertising, or an extra $10,000 on advertising, how much is my demand going to increase? Elasticity is one. If I know the advertising elasticity, I know how much my demand is expected to increase when I increase advertising. Weather elasticity, again, depends how we measure it. My dry bulb temperature is there, precipitation. What happens when those things increase? What happens to my demand? Go ahead, I'm sorry.
Where do we get the number? How do we measure that?
The only way you can really measure it now is with data. In other words, in this case, with past data, right? In other words, I increased, or this other company increased advertising by this much, the demand increased by this much. And that's really the only way to measure it. Questions? Okay. Short versus long-term demand, we talked about gasoline, right? It might be that the price elasticity of the product is inelastic in the short run, right? And in the long run, we buy it. The truth is, I haven't seen a Tesla in Puerto Rico. I've never seen a Tesla out in the street. But I know on the two coasts, when I go back home, I don't go to the coast. I know on the two coasts, they're getting to be a little more popular. I've never seen a Tesla, but I have seen hybrid here. I've never seen an electric car. Does anybody see one or have one?
I know someone the Chevy Volt.
Okay. The what?
Sorry, there's the Volt and the Volt. These things.
Okay.
And basically the Volt is fully electric.
Okay. I was
I
gonna
don't
say
know if it's the one with the B or the B, but
okay.
it's
Probably the one with the B is electric.
yeah.
Okay. I at least to my knowledge, I haven't seen a fully electric car driving around in Puerto Rico. There might be one. I just didn't notice that it was electric. I know they make a funny sound. You don't hear the motor. But then again, when my car, I'm hearing the motor of my car on the radio. So, okay. So basically, we can have something that's inelastic in the short run and elastic in the long run, as people are able to change their behavior and switch away from that product into other products. And like I said, gasoline, any other products that might be inelastic in the short run and elastic in the long run. Okay, heating oil, perfect. We can buy that Tesla home, get those big old solar panels up on top of the roof. Then again, I don't know how well they're going to work in the winter anyway. But there's other alternatives that we can switch out of. Okay, now I'm going to give you guys another example. I told you a while ago that when I gave you that you can measure the system in 2 ways. The way we get in our example, where I take the partial and multiply it by this one price PS or X or whatever it is. And the other way I told you was the percentage changes, just the raw elasticity, raw percentage.
you an example now, and you guys have to figure out how to do it. So I have a microbrewery. They only sell beer, right? And right now, at the beginning of, for example, they sell 8,000 pints a month, right? And they charge $4.50. The average cost of each pint, including overhead, is $4. So they're making 50 cents a pint times 8,000, they're making $4,000 a month profit. Now, what I'd like to do is I'd like to know what the elasticity is, or the own price elasticity in this case, of this product is. So what I'm going to do is I'm going to raise the price. I'm going to raise the price to $4.95 a pint. And on the next slide, you're going to see that when I do that, my demand, or the amount that I sell, decreases from 8,000 to 7,600. It's right there. I was waiting because I was just waiting to make sure everybody was talking. So now, right, I raised it to $4.95. My cost remains the same, $4 a pint, again, including overhead. And when I do that, instead of selling $8,000 a pint, I'm sorry, 8,000 pints, I sell 7,600 pints. So what I'd like you guys to do is calculate the own price elasticity of beer in this microbrewery.
A question for exercise is, what we supposed to find right now
Right now, what we're supposed to find
with this?
is the own price elasticity of demand for beer of this microbrewery. This one. I haven't given you the price or income of their customers, so there's no way we can calculate that. So it's the own price elasticity. So just to remind you, initially, they were selling 8,000 pints at $4.50. They raised the price by 45 cents. And the amount they sold dropped to 7,600. Porque como este es demanda, entonces va a ser negativo. Si uno va a subir, uno sube, el precio sube, pero la cantidad baja.
The actual. To them,
To answer your question, right? The formula is the simple formula to calculate percentage. Right? So in this case, I have price. I take the price, the base to be 495, minus the initial price 450, and divide that by 450, make it a percentage. And the percentage of this is. Okay, well, that's okay, you still go ahead. Over here, I do the same thing, I take the percentage change, 7,600, minus 8,000, that's negative 400 over 8,000, and that's the percentage change in the quantity demanded. Right? So like I told you, right? The way you calculate elasticity, at least for this class, right? Sometimes you're gonna have a formula and you can do it with the partial and you apply the formula, you just change it. Or sometimes you go directly to the raw percentage changes, as in this case. Solamente parte directamente y apoyo los cambios. por eso te doy los números. Los nombres. Yo te digo, ya que esto de acá, ya calculando esto sí. Pero lo tienes a ver. Ok. Vamos a hacer lo siguiente. El campo igual metro. Entonces, sabes que es un problema. Pero lo tienes a ver.
Ok.
Entonces,
Exacto. Simplemente ya.
el porcentaje de aquí, en ese caso no necesito los parciales. Sí, entonces en este caso yo no te doy una forma, no puedes tomar un parcial. Cambio por el negro. Cambio negro. La 7,600 menos comenzamos dividido por 8 en este caso negativo dividido por 8 menos negativo punto sobre ese es el cambio de X. Entonces ahora el cambio porcentual es 496 menos No, porque comenzamos, antes que aumentó el precio, estaba vendiendo. Entonces, ese es donde comenzamos. Entonces, cuando yo cambié, ese quedó primero. Cuando yo aumenté el precio, solamente le puse 7,600. Entonces, 7,600 mandaron 8,000. Y 400 dividido por el de comencé, 8,000. Aquí comencé 450 y aumenté el precio a 4. Entonces, aplico esto. Negativo 0.05. Okay, I think everybody got it. ¿Hay alguien que todavía está? Everybody got it? Here, I'm not using the formula. Like I said, I can, the way you do it depends on what I give you. You don't just give me the numbers. You have to calculate the percentage change. Yeah. So it's 5 negative 5%. That's it. Yeah.
It's elastic.
I like the number.
Ahora, pero esto es producto, o sea, es menos. Si es mayor pero es en el plástico. Less than 1 is
Okay. I think I got everybody, and I think everybody got it. So as I said, right? The way you calculate the statistic depends on what I did. I didn't use a formula this time, and I had people trying to figure out how to do it. So a formula you can't do it. I give you the raw numbers, you figure out the percentage change in the quantity demanded or the percentage change in the price. So the question is, what is the point price elasticity of beer in this example? And everybody got it? It's negative 0.5. Is that elastic or not? Okay, you guys are confusing me. It's less than 1. It's less than 1 in absolute terms. That means it's
less than 1 is defined as elastic.
have to go way back. Okay.
It's 0.5. I'm not hearing anybody say elastic, right? Okay, I guess I'm just sorry hearing, I'm not hearing the end, or for some people, I didn't think I was hearing them.
It's inelastic, perfect. What happened to revenue? Okay. Now, oops.
I know that since it's inelastic, total revenue increase, right? I know by what we talked about, that it shouldn't. Did it increase? The answer is yes, and the way to calculate that is 8,000 times 450, and compared to 7,600 times 495, this is a big number. So revenue increase.
Did somebody do the calculations? I forget what they were. 7,220 versus 4,000. Okay, so it increased a lot.
El income
Question? ¿Tenías pregunta?
I'm just for the total revenue, $7,000
Ooh. Okay.
So the microbrewery make the correct decision to raise the price. In general, at least in the short run, right? We know that with certain items, that they can become more elastic as time goes on. Maybe the customers will get pissed off and try to find another brewery, but at least in the short run, they're sticking with the brewery and paying the extra 45 cents a pound.
Should he raise price again?
Again, if you raise price, I mean, the price is pretty inelastic. If you raise price again, you probably still raise your revenue. Again, you have to measure
In real world, the short term against the long term. Are you going to piss off the customers raising price? And even though you might raise your revenues in the short run, right? Well, they keep coming. And that's just something you have to ask, and that's something that you can't really tell from the point price, the current point price elasticity. There's really no way to tell how it's going to change unless you have some kind of data. So, and in general, that data wouldn't exist for a microbrewery. But
it's one of those questions. At least in the short term, you can raise price again and total revenue would increase.
okay, questions? Okay, I'm gonna cover demand estimation in 2 weeks. You guys got Monday off, Labor Day, so I will see you guys in 2 weeks. Have a great 2 weeks.